Hi guys, so this video is going to show you how to use the calorimetry or Q equals MCAT equation to solve problems to find heat energy. So this equation works pretty similarly to the gas laws equation, where you'll identify the information from the problem, plug it in, and then just use algebra to solve for one of the variables. So we're going to solve number 1 on page 3 together. You'll want to have these written down because probably the hardest part of the equation is knowing which symbol is which. So for Q, that stands for heat, which is a type of energy. So you'll see either heat energy or just heat or energy interchangeably used. That is measured in joules. That's our unit for heat here. The M stands for mass. That'll be done in grams. C is called the specific heat capacity. So as we know, different substances will absorb heat differently. For example, water can absorb a lot of heat before it changes temperature, whereas metals can only absorb a little bit of heat before they change temperature. So if you're looking at page 3, that chart at the top, that's showing the specific heat capacities. And you can see the metals are generally lower and water has the highest one in the liquid state. When we call it specific heat capacity, that's with these units here. And the degrees Celsius sometimes will be in Kelvin. I don't remember from the AL assignment that you'll do, but we can switch out Celsius and Kelvin because they change by the same increments. Kelvin just starts 273 degrees lower than Celsius. And then the final one, that triangle, is the Greek letter delta. And in math equations, that delta means change in. So that's the difference in temperature. So another way you can rewrite that equation, which you may prefer, especially if you're doing the problems on this page, is T final minus T initial, and solve it that way. And this is actually the way I'm going to use it for this one because we have 2 temperatures given. So I'll just plug them in as written. You could do the subtraction first and then plug it into this equation. Either one's fine. So in the first problem, we're going to identify our variables and then plug them into this equation here. Well, actually this one. So we have 740 grams of water. So that's going to be our mass. Pen doesn't want to work right now. And then we have our temperatures. So this is TI, TF, and we need the specific heat capacity. So water is our substance. The specific heat capacity comes from the chart on page 3. In this temperature range, 29 to 46, water is going to be a liquid. Most of the substances that aren't water, it will tell you if it's going to be a solid or a liquid or gas, or you'll only have one given heat capacity. But water, you're expected to know that it melts / freezes at 0 and then boils or condenses at 100. So because in this temperature range water is a liquid, we want the C of liquid water, which is 4.184. And then the rest of that is the units, joules per gram degree C. Ooh, writing is rough today. Okay, so these units, kind of like the R value when we did the ideal gas law, they're just designed to cross everything else out. So this one, we're trying to find heat energy, we're trying to find Q. So we can just plug right into the equation. As I said, I'm using this one. I'm just going to plug in the temperatures as they're written in the problem. So Q equals the mass, so that's the 7.40 grams, times the specific heat capacity, 4.184. And then the temperature goes from 29 to 46, so our final is 46. Keep that 0.0 for sig figs. And then we plug that into our calculator. So we do the subtraction first, then multiply everything out, and we want to round that to 3 sig figs for our answer, which gives us an answer of 526 joules. So that's pretty much what you're doing. You will have problems where you have to solve for the mass or the specific heat or the change in temperature or final or initial temperature, but as long as you can identify the numbers in the problem, you'll probably be pretty good. All right, send me messages if you have questions about the AL assignment.